Good morning students. Today also we are doing one more optical instrument, okay, optical experiment. The aim of the experiment is to find out the refractive index of the liquid. We are using water by using what is convex lens and a plane mirror. So, this is the plane mirror, this is the convex lens and this is the optical bench system we will consider, and this is the object needle, and with the help of this needle we will calculate the image, we will find out the position of the image. First, the ray diagram is this. We will place only the plane mirror. On the top of the plane mirror, we will keep the image or this particular lens, and we will move this particular lens over here and calculate what the object and the inverted image. So, this way we will calculate A and B. A is measured from the top of the lens and B is the distance measured from the top of the mirror. So, this A plus B by 2 will give me the focal length. So, I will measure using this what is a meter scale. So, I will note down the reading of A, B and the focal length of what? The lens. Now, the second procedure is I will put a water over here, and then once again I will find out the position, and then this is A reading from the top of the lens and B reading from the top of the mirror, or top of the mirror, yeah. Over here this is the upper one is the convex lens, below one is the liquid lens, which is you can see over here it is a plano concave lens, and now they act as a combination of lenses. So, when I get this particular image formed, so this is the focal length of what? The combination of lenses. So, AB and this is the AB and this is the focal length of the combination lenses. As you know, the effective focal length in combination of lenses as 1 by f equal to 1 by f1 plus 1 by f2. So, similarly, how can I calculate the focal length of the liquid lens? By using this formula, 1 by focal length of the combination, which is obtained in the second case when I put the water over here on the top of the mirror, and then minus the focal length of the object, that is the first reading when we do only with the lens. Okay. So, this is the observation table. Now, I will tell you next how to take the readings. Now, I will show you how to take the readings. Okay. So, over here this stand represents the optical bench system. So, over here I have a plane mirror. On the top of this plane mirror I will put this convex lens, okay, and I will move this pin on the axis which acts as my object, and I will try to find out a position where the image of this needle and object, this needle coincides and they move like this, means parallax should be removed completely between the object and the image. So, first I will just find out that position. Yeah, now this is the reading. I have got the object and the image coinciding. When I move my head like this, okay, the object and image should move together as we have earlier done in what is a convex lens experiment. Okay. Now, I will tell you how to take the reading. So, now measure the reading. First you will measure what? From the mirror, the first reading will be from the mirror to the top of what is the tip. So, this is nearly 11 centimeter. The other reading will be take the reading from the top of the lens, So, this two reading, now this is 10.5, okay. So, then we have to do this, the A reading and B reading, the average reading will be A plus B by 2. Now, this is called as the focal length of this particular lens, okay. So, the average of these two readings. Now, how to do the second one is I will pour some water on the mirror, on this plane mirror, okay, and slowly drop the water, okay, and make a layer, and now I will place this convex lens over here. Now, you just see that over here now we have a two lens system. One is the glass convex lens systems, and the below we have the liquid lens systems, okay, that is plano concave lens. So this system, this is the effective combination of lenses. Now I will get the image produced by this combination of lenses. I will move again the object on this principal axis, and I will find out a position where again the image coincides, and that distance what I have obtained will be the focal length of this combination of lenses. When you are taking the readings, please remember that you have to remove the parallax from tip to tip. That means tip of one object should be coinciding with the tip of the image. See, now the object and the image needle are moving together. Wait. Yeah, see, object and the image is moving together. So once again we will do the same thing. Okay, we will find out the length from the top of the mirror, this to the tip of the lens, okay, and then from the top of the lens to the tip of the needle. So you will get once again the two reading, A reading and B reading, and we will take the average A plus B by 2. That reading will be the focal length of this average systems. Okay, and from this how to calculate the refractive index of the liquid, that calculation part I will show you later.